Dear students, in this module, I'm going to talk about constructing alpha helices using the Chow-Fasman algorithm, and I'm going to show you a flowchart for the algorithm. To begin with, you know that the Chow-Fasman algorithm helps predict the secondary structures which can be formed out of the amino acid sequence of a protein. In this module, I'm going to focus on the alpha helices only. But before we get to that, let me review the beta sheets and how the flowchart for beta sheet actually worked. So in this flowchart, as you can see, we started by scanning the amino acid sequence, and then we saw if 4 out of 6 amino acids had a propensity for forming an alpha helix. 4 out of 6 here was necessary because alpha helices require at least 4 amino acids for making one full turn in the alpha helix. But if that was not the case and the amino acids were not going to form an alpha helix, then we took a set of 5 amino acids as shown here, and we evaluated if 3 out of these 5 had a propensity for making a beta sheet. So because beta sheets, they require more amino acids, so we are considering 5 in this case. So if that was the case and 3 out of 5 amino acids had a propensity for forming a beta sheet, we extended the sheet in both directions, that is, in both the positive and the negative direction of the protein sequence, and then we evaluated if a situation came to us where 4 contiguous amino acids had a propensity for forming a beta sheet and its average was less than 1. So this actually indicated that you were entering a region which was not very interested in forming a beta sheet. After that, we applied 2 conditions, and we saw that if that is the case and 4 contiguous amino acids do not have an average above 1 for forming a beta sheet, we computed the overall average for the propensity of forming a beta sheet, and if it was greater than 1.05, as well as their propensity for forming a beta sheet was more than the propensity for forming an alpha helix, we finalized the region to be a beta sheet. And we used to do that till the end of the sequence. Now we are going to modify this algorithm and integrate the prediction of alpha helices. So let's see. So this was your algorithm, and you started by scanning the amino acid sequence until you finalize the beta sheet region. But now I'm going to modify this flowchart and include alpha helices as well. So at this step, if 4 out of 6 amino acids had a propensity for forming an alpha helix to be greater than 1, then you should not be considering beta sheets, but you should go for predicting alpha helices. So you extended helix in both directions by 1 amino acid at a time, and you checked for 4 contiguous amino acids which had a propensity for forming an alpha helix falling below 1. So note that this is the same condition here, except that in this case we are checking for 4 contiguous amino acids and their propensity for forming an alpha helix, while in the case of beta sheet prediction we are considering 4 contiguous amino acids but their propensity for forming a beta sheet. So if this condition is not true and that the alpha helix is not to be formed, then you shift the algorithm back towards forming a beta sheet. However, if that is not the case and the sequence wants to form an alpha helix, then you see if the amino acid sequence is greater than 5 amino acids in length and you consider the region to be an alpha helix. However, if the amino acid sequence is less than 5 amino acids, then you may want to consider other options. So, if the sequence is longer than 5 amino acids and the propensity for forming an alpha helix is still greater than the propensity for forming a beta sheet, as shown here, then you still declare the region to be an alpha helix. However, if that is not the case, then you may want to revert to forming a beta sheet. Here. In this way, you can continue calculating alpha helices from the sequence until you arrive at the end of the sequence. So once the sequence finishes, then you can have the alpha helices and the beta sheets ready and prepared in front of you. So in conclusion, by combining the flowcharts for the alpha helices and beta sheets, you have now evaluated the Chow-Fasman algorithm and its working towards predicting the secondary structures from protein sequences. Now the only thing that is left is the beta turns.